Okay, trigonometric ratios. I definitely butchered that. That's fine. All right. So basically what it means, it's just when we have, let's see, when we have a ratio of two sides of a triangle, of a right triangle, sorry guys, of a right triangle and a related angle. So you're like, what the heck does that mean? Well, let's go ahead and read a little bit more. So it says in triangle ABC, there is a right angle, right? Let ABC be a right triangle with acute angle A. The sine of A written as this guy right here. We have sine of A. The cosine of A written as cos of A. And then the tangent of the angle A is written as tan of A, are defined as follows. So what it says, here we're going to look at 3 new vocab words. We have our sine, we have our cosine, and then we have our tangent. Okay, you might see this stuff on your calculator. If we actually go to your calculator real quick, mine looks a little bit different, but it's these guys right here, right? You have the sine, and then you have, the cosine and the tangent, right? This is where those come into play, is this lesson right here. All right, so it says when sine, we're dealing with the opposite leg, the length of the opposite leg of the angle A all over your hypotenuse. So in this case, let me go ahead and change the color of that. So it's all the same. In this case, let's go ahead and look at my sine is in my pink color. If we're looking at angle A, which is right over here, right, we have the length of the opposite leg. So here's your opposite leg all over your hypotenuse. So in this case, they're labeling it as BC, which looks right, all over AB, which is your hypotenuse. Okay. You might see in some circumstances, this is just going to be the opposite. So that's going to be all O over H. Right? And I'll go ahead and add that in later. All right, cosine of A. I'm going to go ahead and do this guy in blue. Where are you? Right? Is the length of the adjacent leg to the angle of A all over your hypotenuse. So if I'm looking at A still, the adjacent leg, this guy right there, your hypotenuse is still your hypotenuse right there. And then it's saying AC, which makes sense. Here's AC, that's the adjacent leg all over your hypotenuse. In some cases, you might see me going ahead and labeling it as A over H for adjacent leg over your hypotenuse. And last but not least, we have then the length for tangent. I'm doing green. It's going to be the length of the opposite leg all over the length of the adjacent leg to that angle A. So the opposite leg is right there, adjacent leg is right there. In this case, your opposite leg is BC and your adjacent leg is AC. In some cases, you might see me going ahead and labeling it O for the opposite leg all over A for the adjacent leg. Now you're like, oh, that's a lot of memorization. But there is a handy dandy way of saying all these guys and remembering these ratios. It's called SOHCAHTOA. Okay, so the SOHCAHTOA, if I were to write it, here's SOHCAHTOA. Right, you're like, what does that mean? If we were keeping it with our sine, right? So sine is the opposite over your hypotenuse. So in this case, I'm going to go ahead and write in the sine is going to be the opposite all over your hypotenuse. Just pulling it from there. Right? Cosine, we said, was the adjacent leg all over your hypotenuse. So here's cosine. Here's the adjacent over your hypotenuse. And last but not least, we have tangent. And that we said was the opposite all over our adjacent. So you guys can use either way. You can use this guy to go ahead and memorize these guys. Or I like looking at this guy because it gives us these ratios right away. Right? Okay, let's go ahead and put everything that I just gave to you, right, word vomit, right into examples. So let's go ahead. It says, find the trig ratio, trigonometric, maybe you got it, ratio, and write each answer as a reduced fraction. So I would go ahead and make sure that your Desmos app is all ready to go. I'll go ahead and get that ready to go as well. Here we go, as it loads. There you go. So we're trying to look for the tangent of S and the sine of S. So in this case, we're referring to our angle of S. Okay, we just learned above that tangent is going to be this guy, the opposite leg, all over the adjacent leg. So I'm going to go ahead and write in O over A just for reference. The sine of S is going to be the length of the opposite leg and the length of the hypotenuse. So I'm going to go ahead and label this guy as O over H. So if I'm looking at my reference angle of S, right, we can kind of go ahead and label the triangle just like how we did above. So across this way is the opposite leg. The angle that, or the side that is not the hypotenuse, is the adjacent guy. And then of course across from your right angle is our hypotenuse. So in this case, our ratio for tangent of S is going to be the opposite of S, which is that 80. Right, that's our opposite. So we have 80 all over the adjacent, which we said is 18. So that's going to be over 18. So we have 80 all over 18. The easiest way to go ahead and find that reduced fraction is if I went to Desmos and I typed in 80 divided by 18. And then there's like this little fraction guy right there that I'm clicking a bunch of times. Go ahead and click on it. And it looks like our most reduced fraction is going to be 40 over 9. So I'm going to say is equal to 40 over 9. And we are done with this guy. Very similar with the sine of S, right? We have the opposite over our hypotenuse. In this case, our opposite was that 80 as well. And then our hypotenuse this time is going to be 82. Same exact thing as the other fraction, right? Go ahead and type in 80 all over 82 in your calculator. And then that most reduced fraction is going to be 40 over 41. This guy is equal to 40 all over 41. And you are done. Okay, let's go ahead and do example 2. Same thing, we're looking at angle S. Here we're dealing with sine. So SOHCAHTOA, right? It says sine is going to be my opposite over hypotenuse. And then cosine, something that we haven't done yet, is going to be the adjacent side, the adjacent leg all over your hypotenuse. So this is going to be A over H. So then, if I am looking at my triangle, right, across from the S is our opposite side. The side that is not our hypotenuse is going to be the adjacent side. And then the side that is across from our right angle is going to be our hypotenuse. So in this case, if I'm solving for sine, which is opposite over our hypotenuse, we're dealing with 63 as the opposite all over our hypotenuse, which is 65. And so our fraction is going to be 63 over 65. You can go ahead and type this in your calculator, but I'm just going to tell you right away that this is the most reduced that we can do for this guy. All right, cosine of s, same thing. We're dealing with the adjacent over hypotenuse. The adjacent side is going to be 16. Your hypotenuse is going to be our 65. And this guy is also down to its reduced fraction. And you're done. Okay, try doing 3 and 4, or sorry, try doing number 3 on your own and come back. All right, so I split up number 3 into two like problems. So it's really 2 problems in one, but we can do both. All right, so there is our reference angle of U. Cosine, again, if we're looking at SOHCAHTOA right here, cosine is going to be the adjacent over our hypotenuse. So I'm going to go ahead and write A over H. If I'm looking at U, right across from the U is the opposite side. The non-adjacent or the non-hypotenuse side is going to be my adjacent side. And then my side that is across from a 90-degree angle is going to be my hypotenuse. So the adjacent side is the 18 all over the hypotenuse, which is the 30. And this guy, I can go ahead and check my calculator. I have 18 divided by 30. That's going to give me 3/5 as my most reduced fraction. And then we are done with that guy. Now it says tan of W. So here we're looking at this reference angle of W. Across from the side is the opposite, which is our 18. The non-hypotenuse side is our adjacent side, which is the 24. And across from our right angle is going to be my hypotenuse. Tangent, if we look up above, it says tangent is going to be my opposite side all over my adjacent side. So it's going to be O over A. My opposite side we said was the 18, and the adjacent side we said is 24. You can go ahead and type in your calculator 18 divided by 24, and that will give me 3/4. 3/4. Right, and you are done. Now go ahead and do the level 2 practice. We're only doing number 1, number 2, and number 3. So go ahead and stop at this guy right here.